Good evening, Professor. So, this is my personal timetable, and the last week I did the correction of my PSA paper, and now it's already accepted. And also simultaneously also looking for the new PSA for the urine biosensor chemicals. So, in the last week we found that, and we already have ordered the chemicals, and it takes 2 to 5 weeks to get that chemical, so it means the 1 month approx. And the third one is the coronavirus biosensor research paper that it will be implemented by me and Prashant, so we already working on it. And the task 4 is the AAO Biosensor research. So we stuck that we use the graphene oxide, and the graphene oxide is very hard for doing the research with this. So we moved to the MUA chemical. So we already Bruce will take care of this, and hopefully he ordered that chemical, and we will get that soon. So in this week, I have planned to continue the draft paper dealing with the Prashant and me, so to write down, and also simultaneously for book the uh, characterization things like AFM, SEM, and FTIR. So that thing, and the second one is the AAO biosensor research things. So we already have ordered the MUA. So simultaneously, we also looking for the SEM characterization. So we have checked that in not in this week, like after this week, we got the chance to book that one, and then we will make 4 or 5 different kind of substrate like what we have. So we different five different kind of things like the substrate and the chemicals to check the surface morphology, and also simultaneously waiting for the MUA chemicals. Then we will start with the MUA to dealing with the AG protein complex, and the MUA, and then antibody antigen. So I move to the next slide. So because of this, because of you and your guidance, your support, this paper will is already accepted and waiting for the proof correction. And I'm very glad to be a part of this lab. Your Under your guidance, we got this opportunity to learn how to dealing with the IDC substrate, and how to check the biosensing things in terms of electronic engineering and the biosensing part. So I'm very happy to uh, say this, and waiting for the proof connection, and hopefully in the future, in the upcoming 6 months, we will get the more and more opportunities and more good accepted articles. Uh, I, and thank you, sir. Thank you so much for your help and guidance. And so this this is the new PSA antibody. Why I'm curious about this product, because the product is a basically recombinant monoclonal antibody. So we have checked there are so many different kind of antibody like monoclonal and polyclonal, but in our case monoclonal is better than the polyclonal. So we move to the monoclonal antibody, so which um, offers several advantages, like batch to batch consistency. It means the bonding is very strong and the reproducibility is very good as compared to the previous antibody. And also the best part is the improved sensitivity and specificity of this product. So it's a long term security of also supply to the binding affinity between the antibody and the X antigen. So it's the animal-free production, and I have checked and I've read the so many papers, literatures, and they are using this product. And on the website of the AppCam, I saw the 8 references of this product. So this one is more and more good, and more efficient, more and more better antibody for our research. So that's why I go with this. And we already ordered this product. So it takes 2 to 5 weeks, like 1 month, to get this kind of this product. And then once we will get this product, so we have to start the experiment. Before to get the products, we have to plan the biosensor recipe. So in this week I'll make it the biosensor recipe, or like the research plan, to show you to how we can use this antibody in our research. And also the same thing for the antigen. This antigen is also having tremendous results, because I saw there are so many papers they also use this kind of antigen. So in a one paper I saw it's already published in ACS physical chemistry. So I saw this antibody and antigen using the same kind of product, and to use the biosensing criteria to check the sensitivity and the specificity, and of course the selectivity as well. So these two products are more good, better than the previous one, and so that's why we moved to this one. And now come to the AAO Biosensor research work. So as we discussed in the last meeting, that we have to go with the new AAO substrate. Like we got the new AAO membrane substrate. There are two different kind of AAO membrane substrate. The first one, like the one is 75 nanometer pore surface, and the second one is 90 nanometer pore surface. So we are curious, and we have already checked that the 95 one with the graphene. So we found that the graphene flakes is already 370 nanometer. So it's like the barrier, or like the obstacles behavior of the graphene oxide with the AG particle. That's why we didn't get any positive response. So we have to go to the MUA chemical. So we have to cancel out the graphene oxide and waiting for the MUA chemical. Then we start with the AG protein and the MUA to start the experiment with the specific antibody antigen, like corona antibody antigen and urea antibody antigen, like this. So we have already have the 3 different kind of AG protein sample, but we go with the 50 millimolar concentration of AG. So we go with this sample, and we cancel out this graphene oxide, because the flake size is very higher as compared to the AO membrane surface, because this flake size is 370 nanometer, but our flake size is the 95. Maximum pore size is 95 nanometer. So it's very an impossible thing to penetrate the graphene oxide or the Aegis protein into the pore surface. So that's why we didn't get any positive response. and we have tried to minimize the flake size of the graphene oxide, but max to max is goes to 100 nanometer or 120 nanometer as per my understanding. So that's because we have already tried to decrease the flake size, but it's impossible thing because that's why we go with the MUA chemical for buying this stuff, and then we have to start the AO research work. So this is the research plan that there are two different kind of research plan we have made. So the AAO surface having a 95 nanometer, we go with that AAO membrane surface. So we first did do the LSPR there, and there are different kind of 10 10 consecutive step measurement. So first we have to check the bare LSPR measurement, and then we have to check the protein and graphene oxide. And of course, graphene oxide is not suitable for this AO research, so we go waiting for the MUA chemical, and the simultaneously we go with the washing with the PBS and EDC NHS, and then using the corona antibody, and then washing with the PBS, and then again put the antigen in five different kind of concentration. So this plan we follow when we get the MUA chemical, and simultaneously also we go with that plan also, because there are two different kind of research plan. The first one is using only the washing with the PBS in each step. So in this step there is no as such washing, so we go without washing. We have to just put on the chemicals like AG protein and the MUA, EDC, and the antibody and antigen without washing. So we have to check that these two different kind of research plan, and so this is the MUA chemical properties, the positive properties as compared to the graphene oxide. The graphene oxide, as I already told to you, that the graphene oxide flake size is very higher than the pore size of our AO surface. So it's very impossible to penetrate the pore surface. So we go with the MUAs because the MUA size is approx 110, so we have to just dilute it and to minimize the surface area. Then we easily penetrate the pore surface, the mu chemical, and then we follow the same step that what we already explained to you in the last slide. So it's a kind of a reference that we found at there are some paper that we found that the MUA chemical is used in this kind of research scenario. So hopefully in a 2 weeks we got this chemical, and then simultaneously also preparing for the SEM characterization. So still we are, me and Bruce are have had a meeting together to understand how we make the chips for the SEM characterization. So tomorrow we have again meeting together to make a plan like how what kind of AO surface, AO membrane surface, and how we can check the SEM characterization. So it's a tentative one. So tomorrow I'll send you for your review that what we have planned for the SEM characterization, and thank you, sir.